What's happening, dogs? Mr. Allen here with some verifying of trig identities in this video. I actually love these types of problems. I used to get frustrated. They're frustrating at first, but they're kind of fun little puzzles. Plus, when we're verifying the identity, it's equal to something. I already have the answer there, right? So it gives me some little focus, maybe a glimmer of hope, right? Okay, for this first one, let's get after it. We got tangent squared theta divided by tangent squared theta plus 1 is equal to sine. So I'm going to only mess with my left-hand side here to get it to look like my right-hand side. Cool? Let's talk about some things that we shouldn't do first, okay? First one is I can't split this into two fractions. My denominator, if it has a sum or a difference, cannot split it, okay? If this was flipped, then you can split into two fractions, but not when the denominator has a sum or difference, okay? No. Another option that actually could work, but I would say is not necessarily the best way in this one, is rewriting tangent in terms of sine and cosine. Oftentimes if we see tangent, cotangent, secant, cosecant in these types of problems, we rewrite them with sine and cosine. That is a common strategy. Not the best move here in my opinion. I instead am going to use Pythagorean identities. When we have something squared, there's the potential to use some Pythagorean identities. And that denominator right there is equal to secant squared theta. So we have tangent squared theta over secant squared theta. I'm not going to write the sine squared anymore, right? We're just going to deal with that in a little bit. It gives me a little more room to work too, okay? So secant squared theta is the same thing as 1 over cosine squared theta, right? Tangent squared theta divided by 1 over cosine squared theta. Could I then multiply by the reciprocal? You see that? That's official. That's official stuff right there, okay? So I'm going to have tangent squared theta times cosine squared theta. Perhaps now it is a good time to rewrite tangent squared theta in terms of sine and cosine. Tangent squared theta is sine squared theta over cosine squared theta times, I'll even put this guy over 1 so we can see it. Cancel, boom. We're left with sine squared theta equals sine squared, theta. Boom. Done. America. I like it, man. It's dope. It's awesome. Fantastic. You may not have to show all these steps. Like, I think when I did this step here, I probably could have rewritten tangent squared theta as this right here to save like one step, you know? So as you get going with it, you know, there's certain ones you have to write a decent amount, but there are some things you can skip as long as your teacher's okay with it. So double check with them before you start skipping steps in these problems, because you skip too many, now you haven't proved it, right? You haven't verified it. You can't just be like, oh, yes, it is. Good. I skipped all the steps. Just trust me. It's good. Okay? Can't do that. Alrighty, next one. Cosine of theta divided by 1 minus sine of theta minus tangent of theta equals secant theta. This one looks a little rough. So, again, we can't break this apart into two fractions here because I have a difference in my denominator this time, right? That's no bueno. It's already in terms of sine and cosine here, and that's not really going to do much there, maybe just yet. Maybe later we'll move that tangent. But there's an opportunity to create some Pythagorean identities, okay? 1 minus sine of theta, if I were to multiply by the conjugate, 1 plus sine theta, in both numerator and denominator, 1 plus sine theta. Sorry, it's a little bit hard to read there. I didn't have much space. Well, now, that foils out, multiplies out to 1 minus sine squared theta. Let me write that down. I'm going to keep the numerator as cosine theta times 1 plus sine theta over, and then when we FOIL this out, multiply it together, I get 1 minus sine squared theta minus tangent theta. Leave the secant for now. Well, 1 minus sine squared theta, and you're like, wait, how did we get that? Well, the 1 times negative sine and 1 times positive sine will cancel out. So we're just left with the 1 times 1 and the sine theta times negative sine theta. Cool? This right here is cosine squared theta. Oh my god. Leaving it in factored form in the numerator. That's a good move, right? Don't multiply things out unless you think it's going to be helpful, okay? Don't just do it just to do it because you're used to doing it. Do it because you think it might be helpful. I didn't think it was going to be helpful here, and I was right. So we got cosine theta times 1 plus sine theta over cosine squared theta, still minus tangent theta. This is going to get rid of one of those squares. Boom. And now I have 1 plus sine theta over cosine theta minus tangent theta. Now I'm thinking in terms of sine and cosine. might be good here, because wouldn't this negative tangent minus tangent, that's sine over cosine, right? Hold up. Sine theta, cosine theta, sine theta over cosine theta. I have common denominator, don't I? I can just add my numerators. What happens to my sine of theta and the negative sine of theta? Those guys are gone, and I have 1 over cosine of theta, which, oh my goodness, that equals secant of theta. Dunzo. Dude, it's kind of fun, right? As you work through and things just kind of start to unravel and get really nice and simplified. It's kind of awesome. All right. Well, there we go, guys. A couple examples on verifying identities. I got a couple more, in here. So if you need some more practice, or if you have a request of like a certain one or a certain type, let me know in the comments. Make sure to like and subscribe, and stay dope.